Right, okay, so we're going to add 1.5 to an 8 and 5 to 2. Okay, so we're saying 1.5 plus an 8. What's the answer? Yeah, 1 5/8. So we know what the answer is. Well, we know what it is in decimal anyway. But we'll whatever we get at the end, we'll convert it and find out what it is. Okay. Right. 3-step process. So we need to unnormalise first. I don't know how you spell unnormalise. It definitely hasn't got a Z in, unless we're in America. Then we can add. Then we have to renormalise, because we want to hold it as precise as possible. Okay, so just these 3 steps. So let's just put our 2 numbers first. So let's take the 0.1100. So this was 1.5. And we know it's normalised. Why do we know it's normalised?
Because the starting point's before the 1 and 0.
Yeah, because all you've got to do is look at the left-hand side. The first 2 bits are different. It's normalised. Okay? So we know it's normalised, so we know we've got to unnormalise it. So let's unnormalise it. Okay, so the exponent is 1. So we're going to make this bigger, because it's positive. So we're going to move the binary point that way. We're not bothered about what the number is. We don't care. We're just going to use it for our addition. So our first number that we're going to add up is going to be 1.1 and then 3 zeros. Okay, so we're going to add that to something else, which we've got to work out in a sec. Okay, so the second number was an 8th. So that was 0.1 and then 4 zeros. And then it had an exponent of -2. So this one's going to get smaller because it's negative. So to make it smaller, we can go that way with a binary point. So let's just pad this first with some leading zeros. Just take the sign bit and it's what we call sign extending. Okay? Right, so we've got to do 2. So we're going to go 1, 2. And if you get confused between, which way do I take it? If you look logically, if I put the binary point there, I have made that smaller, haven't I? Yeah? Because I've pushed that bit that way. So it's gone from being a half, quarter, it's gone to an 1/8. Okay? Right, now we can write this down, but we must line it up. The binary points have got to be in the same place. So we've got a 0, and then we've got 0, 0, 1, and then a 0. And if we want, just for sanity's sake, we can put a leading 0 on that. In these questions, if you get asked to do one, it is at this point where you're gonna cock it up. The rest of it is just the process. This is a copying down exercise, copying down properly. Now, from what we did the other day, all we've got to do is add these together. Just go through the columns, starting on the least significant bit. So 0 and 0 is 0. I better do it on that side, otherwise I'm going to end up in a diagonal mess. So 0 and 0 is 0. Oh, my pen's dying. 0 and 1 is 1. 0 and 0. 1 and 0. There's my binary point. 0 and 1. 0 and 0. Okay? So that is the answer to the addition, but I've got to do step 3, normalise. Alright? So looking at my answer, it's a positive number. We can see that because the sign bit's 0. So I need to put the binary point there to normalise this. So I'm going to move it just one place. So I'm going to go and I'm going to put it there. So the mantissa, once it's normalised, is 0.1101, and then it was supposed to be 6 bits, so we need to make sure we have that 0. The magnitude of the exponent is 1. We went left, so it's positive 1. So that, if I get asked to add those 2 numbers together, 1.5 and an 1/8, and they might give you the floating point directly, that's my final answer, not that. I would hope that the exam board give you method marks. So for the process that you've been through, the You'll get a mark for unnormalising, I would have thought. You get a mark for adding properly. They're testing you can do addition. If I was setting the paper, I wouldn't even bother doing integer addition. There's no point. They might as well make you do this. It's the same thing, isn't it? It's the same process. Okay? And they'll give you a mark for getting the normalisation at the end. How many marks that's going to be, we won't really know until we get a proper live question. But there's going to be a fair few marks on that. So this is going to be a gifty type question. Okay? Right. We said the answer should have been 1 5/8. So let's just work on this and now convert it back to decimal. Just to prove it to ourselves. So I've got a floating point number. If I want to convert it to decimal, I start with the exponent. So the exponent is +1. You'll get a mark for identifying that if you have to do a conversion. So +1 means, make it bigger. Move the binary point that way. That will make the number bigger. So I'm going to go, it's only 1, so it isn't going to take me long. Always put the arrow in. So you're proving to the exam board you know what you're doing, which is always the key. Right, once I've got my point in the right place, I can put my column headings in. So I've got half, quarter, eighth. I don't have to go any further because that's the 0. And you can see if we look at it, it's magically 1 5/8, like Jack said at the start. Okay, everyone happy with that? Right, let's do the other one. So the other one was add 5 to 2. What's the answer going to be? 7, yeah. Audience participation is preferred. Okay, I've just shook my pen up now. So 5 + 2, 7. And again, this is actually super technical, but the actual numbers we're working with are ridiculously easy. Okay. Right, so we've got what 5 was. So we've got to mess about with that one first. So let's just write down what format 5 was in. Okay, so an exponent of 3. We need to unnormalise it, step 1. So the exponent says 3 + 3. So we need to make this bigger. So we're going to move the binary point to the right. So 1, 2, 3. Okay. You what? Are you alright? Yeah. Right, okay, so that's what my 5 is going to look like for my work. So I've got 0.101.00. And we're going to add that to the value for 2 when we work that one out. So 2 was 0.10000. And it had an exponent that was +2. So starting with the exponent +2, so that means make it bigger 2 places. So let's move the binary point to the right. 1, 2. Again, the bit where we're going to cock it up, transferring this. So put the binary point in, and you can see we've got some zeros that way. There's no point in putting the 3 on, it doesn't matter. And then we've got coming this way, 0, 1, 0, and we'll just pad that 0 out. Do the sign extension. So that's the arithmetic we're going to do. So we've done step 1, unnormalise the 2 values. You've got to do that, otherwise you can't just add them directly. Okay? And then we just need to add them up. So you can see we've got 0, 0, then we've got a 1, let's put a binary point back in, a 1, 1, and a 0. So we've got a positive number still, which is good. Okay? And you can see actually, because that's not normalised, you can read it as 7. Everyone see that? 7? But let's normalise it. So to normalise it, we're going to go find the sign bit, find the last 0, because it's a positive number. That's where we need to move the points. We're going to go 1, 2, 3. We're going to put the binary point there. So my mantissa should be 0, 0. Exponent magnitude is 3, because we moved it 3 positions. We moved to the left, so we need to make it positive. So it's positive 3. And that is my final answer. Okay? Everyone okay with these? You're doing something that's really, really deeply technical. But like a lot of the stuff we're doing, it is a process. You might not have ever heard of the process or seen the process. but the process isn't massively complicated. Most of the things in computer science, the processes are inherently simple. But once you start putting a lot of these things together, you can make something complex. Okay? Right, I'll just stop that.